And hello everyone, welcome back to a new video. So in the previous video we talked about modules. Today we'll be getting into OOP. I personally don't like any OOP in any language except for C++. So this is painful for me too. But anyways, let's get started. Now what is OOP? So you have two types of programming things, methods, ways that I know of at least. One is called procedural programming, or PP for short, or object-oriented programming. This can also be known as FP for functional programming, so functional programming. Anyways, and this is OOP. So up until this point, you have only been doing this, procedural programming or functional programming. That's basically when your entire programming language or your entire program exists of only functions, or in your case, defines. Anyways, and that's basically, yeah. So that's what we've been doing this entire. We use def, and we went lol, print hello. That's procedural programming. Very simple, very beginner friendly, very easy to learn. That's why mostly everyone always starts with that, because it's so much easier. Object-oriented programming, on the other hand, is in this way we kind of think of data as normal data. We don't see it as something, it's just data. In object-oriented programming, data is seen as an object. For example, you may have a person object, and that person object may have values attached to it, such as where it is at this moment, or a player object, even better, because OOP is used a lot in making games. You may have a player object, and that player has an X and a Y position, like where it is on the map. And that player may also have its own little values, like what's its name, how fast can they run, how much HP do they have. You know, it's kind of like grouping a bunch of information or data together. Where with procedural programming, it's just kind of all flying or laying about, and you just use it. Now, whether you use OOP or PP is up to you. In every language except for C++, I use procedural programming or functional programming, and only in C++ do I use object-oriented programming. Well, it would kind of be stupid to use C++ and not use object-oriented programming, considering that C++ is literally object-oriented version of C. But anyways, enough of C++, this is Python. So let's get into OOP. So first thing we can do is we can create a class. Now a class is what you use with object-oriented programming to define an object. So let's create a student maybe. And that's actually very nice of Sublime Text. It literally filled in everything. Anyways, then we don't actually need anything, so we can just plop. You can actually remove that if you want to, so we're not using anything. We're just going to stick to the basics right now. That doc string, we can remove that. And do we need arguments? Yes, I believe we will. So I'm going to create a name and a major. That's really nice of Sublime Text to do that for me. Not gonna lie. And maybe like let's say best subject or something. I don't want to create a bunch of subjects at once. Anyways, and yeah, there we go. We'll talk about all this in a second. We can remove that. And boom, we have created our first object. Wow. Anyway, so what's happening here? What's going on here? Basically, we're creating an object. That's all we do here. Then here, we're defining the init method. This init method, basically, it's the constructor. It builds this object right here. Whenever we call this, it's going to call this, or whenever we create this, it's going to call this. You'll understand in a second. And in here we have to call it self, because Python is selfish. That's how I like to kind of think about it. And it's kind of, if you use other programming languages, this will be known as this and not self. But if you don't know, then just think of it as self. And in here you have arguments, which basically just includes information, which we'll get to in a second. Then here it says self.name is equal to name. So here we're saying this object's name is equal to this thing right here. This object's major is equal to this thing right here. This object's best subject is this thing right here. Now, basically what's happening, I'm saying basically so many times right now. So we could actually even rename these if we wanted to, or even these if we wanted to. They don't have to be the same. It's usually just seen as the way we do it. We just give them the same name. Some people like to go here and just give them like a P or an underscore or something like that. I don't do that because I don't like it. I just don't do it. So let's just use this for right now. Now let's create this object. So underneath it we can actually go something like student, capital S, student1 is equal to a student with a capital S this time, because objects usually become capital letters, just so we know the difference between an object and a function. But you know, it's up to you, but I recommend you do. Then we can give it a name. We don't have to worry about self. Self is just calling itself. You don't have to even think about it. It's just there. It's just kind of referring that this exists inside of this, in a way. We can start with name. So then here we can call this Timmy. And Timmy, he does, why is major here? This guy's in school. Shouldn't have a major. We can maybe say grade. Anyway, so then we can go for best subject, which we can say is IT. And he is in grade 10, for example. And this is a grade now, so we can actually just see B. There we go. Anyways, so we just created our first object, or first thing, if you may. If I may, I mean. So you can go something like print. I'll explain a little bit more in a second. Don't run away just yet. And we can say .name. So the student .name. Let's quickly run this and just see what we get. Let's clear this. We get Timmy. Alright, so now we're getting into what's actually happening here. We are saying create a... Okay, let's skip this. I've already explained this. So here we're saying student1 is equal to this student. That's this thing right here. And then in here is basically everything that will exist, or they doesn't have to be everything, but most of what that will exist inside of this object. So Timmy right here, that is this thing's name, or this object's name. IT, that is his or her best subject, and 10, that is their grade. We may understand this in an easy way, you know, so we can tell it it's grade and stuff like that. So here we can go like student1.grade if we want to, and we can then get the grade. So as you can see, it's like kind of grouping things together, grouping a bunch of relevant information together. What makes using object-oriented programming nice is you can do something like student2, for example, is equal to student, and you can say Jessica, her favorite subject is woodwork, and she is in grade 12. Now if we were to go student2.grade, then we would get 12. If we go student1.grade, we would get 10. So basically we're creating two objects that holds relevant information to that object within variables, you know. So here we can even go name if you want to. So name, and then we'll get Timmy, and we'll get student2.name, and we'll get Jessica. So as you can see, it is just containing things together. Now one thing actually you would see a lot is people putting their objects inside of a different folder. So we'll go student.py. I don't know how this happened. I think it's just the way, because object-oriented programming is very focused on looking neat. It's very focused on staying organized. That is why it exists. If you use functional programming, your code might start looking very unorganized very soon. But if you use object-oriented programming, you can actually organize everything much easier. But there are reasons to why you may or may not want to use it depending on your situation. I like to use object-oriented programming for my more important projects and procedural programming for the less important ones. So if I'm busy creating a game, it's object-oriented programming. If I'm busy creating just a simple application for just me to use and nobody else, then it's just going to be procedural. But anyways, then here we can just say from student import and student. So we're just going to import the class, which means we can remove this. And now if we were to run it, you know what, I don't think I saved the file. I think that's what the problem was. Whoops, that's a whoops on my side. Yes, there we go. I didn't save the freaking file. Anyways, so basically we can then create a file for each and every object, and we can keep it organized, all of them within their own files. Or we can put it all inside of the same thing, but then it kind of also messes the whole point of it in some way or form. But anyways, so yeah, that's one way you can use it. We can also give these things like their own little functions as well. These are called auxiliary functions. Let's leave that. Let's first get getters. Now a getter is basically to get something from an object. We'll dive deeper into objects later as well, but for right now we can just do the basics. So we can do something like define get name, for example. It will take in self. And then we can just put all the functions and stuff inside of this class, or inside of any class, will take in itself. Why? Because it needs to know that it's related to this right here. But anyways, then we can just say return self.name. And now we can go here, and if I say student2.getName, then boom, it returns Jessica. Now, of course, I could have just gone name, but it's not necessary, and a lot of times people would say you should rather use getters and setters instead of doing it manually from somewhere else. Now, what's a getter? I mean a setter, because I just talked about it. So a setter is a way to set something to a different value. So let's go, for example, define set name. And we can say self and name, or new name if you wanted to. And here we can say return, damn it. And here I can go something such as self.name is equal to new name. So self meaning this object's name is now equal to this name. And that's basically what we're saying. So if we say get name, and then we say set name, and then here we can do something like Nord. Now, none. That's because it doesn't return anything, so I shouldn't print that. Anyways, so here we can say Jessica, and then it turns into Nord. So here with getName, that's how you change the name. Of course, you can also do it from here, but it's kind of also defeating the purpose, because object-oriented programming is also a way to give yourself a more security in your code. And if you're doing this, if you're not doing this and you're actually going like student2.name is equal to whatnot, then you're basically removing that security bonus you're getting. There's a lot of benefits of using object-oriented programming, and there's a lot of benefits of using procedural programming. It's up to you which you prefer and you use. Now we have auxiliary methods. So auxiliary methods. Why am I teaching you the names of everything? That is because I had to learn it in school and I didn't like it. So now you have to learn it yourself. But anyways, getter and setter are kind of a must learn anyways. Auxiliary, yeah, you might hear it, maybe not, depends. And auxiliary methods are just basically a little thing. For example, let's say does pass, and we can say self mark. basically this will determine if the person passes. So if Mark is less than 20, less than 40%, or 40 in this case, then print or return whichever you want. So return false, or they failed, else, or you can just return true. Now what this basically does is we can go here and we can say, we can remove all of this actually, and we can say if student2 dot does pass, and let's say they got 50%. So if they do pass, then print they passed, else print they failed. Run that, they pass, but as soon as you give them a 20%, then they failed. So basically, auxiliary methods are just functions that doesn't return or set anything specific here. So yeah, that's kinda what I wanted to explain. There's also one more thing I actually want to show you. Another way you can do things. So let's say you want to set a student, you want to give them another thing here, because you don't always want to give everyone something new. So let's go here, then we can go something such as set attribute, which means set attribute, and you can do something such as saying student2, give them their things such as a last name, and make it Harmonious. And then if you print student2 dot last name, then you will get Harmonious. You can also go student2 dot name, and then you get the whole name, Jessica Harmonious. And then that's how you can add like a new thing here if you only want some of them to have it, or if you later on decided you want to add something, you don't want to add it here, then you can do this. You can add an attribute, because these are theoretically called attributes. You can also change attributes if I'm correct with this, so name, and then if we remove this, now the name is going to change from Jessica to Harmonious. It is name, right? Yes, it is name. So yeah, now the name is Harmonious. You can also get certain attributes. So if you don't want to use .get or create your own getters and setters, you can say get attribute. And let's say we want to get a best subject. I'll probably have to say from who though, so it would be smart of me to do this and say student2 woodwork. As you can see, it is woodwork. Also get name if you want to, so name, and they're Harmonious. So yeah, that's the basics of object-oriented programming. And yeah, thank you for watching. I hope you all enjoyed. And yeah, see you all in the next video.